Number one, a boy of mass m1 standing on a smooth horizontal plane a boy of mass m1 standing on a smooth horizontal plane of ice throws a ball of mass m2 horizontally on the surface of ice. On the ice. If D be the distance between ball and the boy after time t, find the work done by the boy in throwing the ball. So in this problem, there is a boy he is throwing a ball. The mass of the boy is m1. The mass of the ball is equal to m2. He is throwing a ball. Actually, he is throwing the ball horizontally through this ice. And after time t, the separation between ball and boy is d. Now you have to calculate the work done by the boy. We know when two bodies are m1 and m2, there are two bodies. Before throwing, the total momentum of the two bodies is equal to 0 because the boy is in rest and the ball also in rest. So total momentum before throwing is equal to m1 into 0 plus m2 into 0 is equal to 0. But as the ball is thrown, the ball will move towards this direction and the boy will move towards this direction according to law of conservation of momentum. So according to the law of conservation of linear momentum, if the velocity attained by the ball is equal to v2 and velocity attained by the man or boy is equal to v1, m1 v1 plus m2 v2, this is the momentum, final momentum is equal to 0. if the velocity of ball is equal to v2 and that of boy is equal to v1 after throwing the ball. Okay. The distance traveled by the ball will be by ball in time t is equal to x2 is equal to v2 into t, and the distance traveled by the boy in time t is equal to x1 is equal to v1 into t. So the distance, this distance, d, separation after time t, d is the distance between ball and the boy after time t. So initially, we say initially the boy and ball was at the same point, and finally the ball moves through a distance and boy moves through a distance, and the separation between boy and ball is equal to this distance plus this distance. So this is x1 and this is x2. This distance is x2 and this small distance is x1, x2. So x1 plus x2 is equal to d. That implies v1 plus v2 into t is equal to d. So this equation number 1 and this equation number 2. From equation 1 we get, from equation number 1 we get v1 is equal to minus m2 v2 by m1. Okay. Now this is equation number 3. So when the boy gains a velocity v1 and the ball gains a velocity v2, the kinetic energy of boy plus ball is equal to Ek half m1 v1 square plus half m2 v2 square is equal to half m1 v1 is equal to minus m2 by m1 into v2 square. So this is equal to, this becomes m2 by m1 square into v2 square plus half m2 v2 square is equal to half v2 square common m2 square by m1 plus m2. This is the expression for energy. Now v1 plus v2 into t is equal to d. v1 plus v2 into t is equal to d, or v1 in place of v1 we can say minus m2 by m1 into v2 plus v2 is equal to d, or 1 minus m2 by m1, 1 minus m2 by m1 into v2 is equal to d. So v2 square, put v2 square here, v2 square from this equation number 3, equation number 4, equation number 5. By combining equation number 4 and 5, we will get an expression for, by combining equation number from equation 5, we get 5 and 4. We get EK is equal to half. V2 square means d square by t square whole divided by m1 minus m2 whole square into m1 square into m2 square plus m1 m2 whole divided by m1. It may be simplified also. So this is the expression for kinetic energy of the system. And from work energy theorem we know the work done by the boy is equal to gain of kinetic energy system. So we can say the work done by the boy is equal to gain in kinetic energy of the system. So this is the problem, and this expression can be simplified. Okay. Now there is another problem. A bullet of mass m, a bullet, problem number 2. A bullet of mass m moving with velocity u strikes a block of mass capital M. Which is free to move in the direction of motion of the bullet and embedded in it. Find the loss of kinetic energy of the bullet. Answer. There is a bullet. This is the bullet. And the velocity of the bullet is equal to u. And mass of the bullet is equal to m. It is moving with velocity u, strikes a block. This block has mass capital M and it is free to move along this direction of the motion of the bullet. After striking, the bullet is embedded inside the block. Find the loss of kinetic energy of the bullet. Now, initial momentum. Actually, to solve a problem, you have to go through the formulae. In case of work or energy, conservation of momentum formula, conservation of linear momentum formula is more fundamental. So, we at first apply the law of conservation of linear momentum. So, from law of conservation of linear momentum, initial momentum, actually the bullet was moving, the block was not moving, so the initial momentum was only momentum of the bullet. So initial momentum is equal to am into u. And finally, the bullet is embedded inside the block. That means the velocity of the bullet and the block are same, is equal to am. So the embedded mass m plus m, and we suppose the velocity of the embedded mass is equal to v. Right here, let the velocity of embedded mass, that means the mass of the combination, embedded means combination, two bodies, is equal to v after strike. Okay, so we can say v is equal to mu by m plus capital M This is equation number 1. Now loss of kinetic energy means the initial kinetic energy minus final kinetic energy. Loss of kinetic energy is equal to initial kinetic energy minus final kinetic energy is equal to half mu square. Actually, the kinetic energy of the block was 0 before collision or before striking. So initial kinetic energy is equal to only kinetic energy of the bullet, and final kinetic energy is the kinetic energy of the embedded mass minus half mass of the embedded body is equal to m plus m. Mass of the embedded body is equal to m plus m, and velocity of the embedded body is equal to this mu divided by m plus capital M square, half mu square minus this, okay, is equal to half m u square common, m u square common, so this is 1 minus m plus m square, that means m plus m, and m has been taken common, so here m square, 1m remains, that is equal to half mu square into capital M by small m plus capital M. This is a positive quantity. Now inspect this expression. Delta E, loss of kinetic energy, here we write again, delta E is half m whole divided by m plus m u square, and this is positive quantity, this is positive quantity, this is positive quantity, this is positive quantity, and this is square, so it is positive quantity. So delta E is greater than 0. Delta E is greater than 0. That means the problem has been solved. Now a question here: when this bullet strikes the block, there is a loss of energy, but from the principle of conservation of energy, we know we cannot create energy. Energy remains same. So what happens to the lost energy? Now I am giving a question to you. You must solve it independently or think independently. So this is the expression for the loss of kinetic energy. Now the question is given here for your thinking. What happens to the, or what is the significance? What is the physical interpretation of energy loss? What is the physical interpretation of loss of energy. You must write down this question, answer of this question. And in next class, I shall discuss about more problems. So this is number 2 problem. Okay, thank you for watching your class.